Login accepted.
Virtual machine templates, and then make sure that you can access vSphere and see your templates. I'll give everyone about like 5 or so minutes to do all that, and then we'll start with the presentation for this week. Oh, there's a password policy. So, do you know what the password policy is?
Just make it longer than 8 characters.
Yeah, use good password practice if you're not able to register. So yeah, if the link from Google Doc doesn't work, we did have everyone set up and configure their SDC VPN week 1. So you have to make sure you have the VPN turned on, you're connected to the virtual private network. And if you haven't done that yet, you won't be able to do the lab for this week. So maybe go back to the week 1 homework, which is posted, I believe, on the Discord and also our website and Canvas if you have access to the Canvas, and set up and configure your VPN if you haven't done so yet. Never mind, we're fixing the link. Sorry, should have been .cal_polyswift instead of .sdc. So it should be fixed now. There's not a username policy as far as I'm aware. For
It have to be less than 16 characters.
first 3 Sterling, it might have to be less than 16 characters. But if you do register and it doesn't direct you back to the homepage, just go back to the homepage manually and try logging in with the account you just registered. And if that still isn't working, we can give you some additional help.
Also, if it still airs out, your username may be taken. There's a lot of users, so just a heads up.
To the person asking about after they deploy the VM pod, the login for the VMs are in the homework doc. For the Cisco router, I believe it's the default Cisco login, which is username is Cisco and then password is Cisco 123 exclamation mark. I can add that to the homework doc too. Update that if anyone needs it, but y'all don't need to actually get started on the homework yet. We're gonna go over some slides first, so you don't have to worry about that as of now. I'll give everyone like 2 or so more minutes and then we'll get started. All right, some people are getting errors trying to deploy their VM template. We're gonna work on that during the lecture, but we're gonna get started on the slide soon anyways. So if you're having an error trying to deploy your template, don't worry about it for now. We're on that. Caleb asks, is the site supposed to do anything after you type in username and password registered? Yes, it's supposed to redirect you back to the home page and you should be able to log in. If it's not doing anything, you might want to try going back to the homework and using the new link that we changed it to. That might fix your problem. But yeah. All right, we're gonna get started for this week. So if you're having problems, Evan is working on addressing that right now. But we're gonna get started with the slides. Oh, Evan, do you want to introduce yourself really quick?
You can introduce me.
All right. This is Evan. He used to be on CCDC and a moral supporter for CPTC, and now he's just a systems engineer at Boeing. So sad. What happened? And I'm Dylan. I'm a fourth year CS student. I'm going to be the CCDC captain for this year. Last year, I was the secondary Windows person for CCDC. I'm co-director of competitions for Swift, and last year I was a Swintern. I'm a big mango enjoyer. I like mangoes a lot, and I'm really bad at Valorant, but I play it a lot. Our agenda for this week is first, we're going to be going over a really high level introduction to networking. Then we're going to go over competition networking. And finally, we're going to be going over the client server model and firewalls. And then we have a lab at the end. All right. It's time to do some networking. Just for a quick little example, this would be an example of a really basic topology of a computer network. You have your router connected to the internet, and then you have a firewall. This could be on the router, this could be on the switch, this could be a hardware firewall. And then the switch is used to connect multiple devices together and handle different virtual networks, and it basically allows all the different devices on your network. So these two workstations and these two servers in this example to all be connected to the same local network and then be able to hit the internet. This is an example of a less basic topology, but this might be a more realistic example of an actual company computer network environment, where on the left you have sort of all the workstations for development and your different servers for development, and then you have a firewall in between the development side of things and the actual production servers for the company, which are then connected to the internet directly. If y'all have any questions about this, there's a good chance they'll be addressed at some point later in this presentation. So if you're like really confused right now and you don't know I don't have any idea what you're looking at, that's fine. If at the end of the presentation you still have questions, we can definitely answer them. All right. Just a heads up, I don't think the 2022 server doesn't have any more. Okay.
Yeah, the image got cloned to the wrong thing.
Oh, that's weird. Yeah, that's the issue that we're addressing right now, actually. So we're dealing with that at the moment. So don't worry. You don't have to actually get started in the lab until the end of the day. So if anyone's getting issues or errors with the lab, just stop doing anything. We're going to delete all the pods and you're going to redeploy them eventually. So just don't worry about it for now. Yeah, so I'm going to start explaining what network devices are. It isn't just computers. It can be anything connected to the computer network. So that could be computers, it could be phones, routers, switches, cameras, basically anything with a working network interface card or NIC, which can have either a wired or wireless connection to the internet, counts as a network device. So lots of things can have a NIC. In smart homes, things like light switches can have a NIC. You can control lights in different parts of your home through your computer network. It can be pretty much any piece of technology can be interfaced with a network. Some example of lingo that we'll probably be covering today are IP addresses, subnet masks, which are basically ways to manage sizes or I guess conserve IPs. And then we have routers and default gateways, which have to do with routers, services, protocols, ports, all these good things we'll be talking about today. Here's another example of lingo I found on my Spotify the other day. Don't know how that got there or why Spotify has it, but yeah.
They've all been calling it like.
All right. So in this example for subnet masks, as you can see on the top is an example of an IP address. There's 3 octets. So each value, yeah, who leaked my Spotify? Each value in the subnet mask, each octet, there's 4 of them, and they're all separated by decimals. Can be between, or in the IP, sorry, can be between 0 and 255 because they're defined by 8 bits of data. They're 8-bit integers. And usually for local IPs, as we can see here, the first 2 will be something like 192.168 dot something, and that's the way that you'll be able to identify different subnets and different devices on your network. The subnet mask, just for like a really quick high level explanation, is basically showing for your computer network what is always going to be sort of set and defined and what can change. So it basically takes the IP and the subnet mask and does some sort of mathematical comparison between them. And this sort of shows that on this network, that the IPs will always be 192.168.1 dot some value, and that value can range from 0 to 255. So now we're going to talk about why we should care about computer networking in the terms of the competition. Don't trip. Marshall, you want to explain this one?
Oh, yeah.
You want to?
Yeah, so if you can see that wire right there, you can see it's not,
Hold it close to your mouth.
yeah, that wire is not very held down well. It's not very taped down. It might be hard to see, but they kind of tape the tape to itself instead of the ground. And so while there's a better picture of it, you guys, what you should know is that that hallway right there is a very busy hallway. We kept running through it each time since. Yeah, sorry, this is at CCDC NATS, so it's a very high stress and very quick environment. You kind of need to run. If you're like trying to get something done as quickly as possible or like use the restroom, you kind of want to run as fast as possible because 5 minutes may cost you your entire network. So a lot of us are going through this area, including me. And this area is not very big. If you can see to the left, there's a chair there. This hallway is maybe as wide as 1 person, with the chair half as much. And so on day 2, the inevitable happens. I'm kind of running through it, and because the wire is raised, my foot gets snagged, I trip a bit, and then the entire room goes silent because that cable right there was powering our switch in our room. So everything goes offline. That was a very fun and eventful day.
Yeah, we had all of our Windows services down which were hosted on premise for an SLA, and we got like minus 300 points for that until we got it resolved after, which was kind of crazy, but just like a little funny story. All right, so here's an example, or here's sort of a really high level overview of the general competition topology in CCDC. I'll really explain how this works. I'll start with the core router. The core router in the competition is sort of what allows all the different networks in the competition, all the different teams to access the internet, access public internet. Everything goes through the core router, and then connected to the core router is for blue teams, our pod router. Every team has its own individual pod router to handle their own network and their own routing, and all of the devices for the most part, besides I think cloud services, are connected to this pod router. So all your servers, all your workstations, all your laptops are going through this team router. And usually your IP range is 192.168.1. something, right? Also connected to the core router is the scoring engine, which basically goes through your pod router and checks and makes sure that your services are up and running at all times. So although all this other stuff on the right is usually out of scope for you to touch during the competition, the pod router, I believe, or the switch is usually in scope during the competition for you to manage and work on. So it's really important that you don't mess up your networking, or else the scoring engine can't see any of your services, and then you get no points for anything. Also connected to this network is the red team, which is the offensive team during the competition that's constantly trying to exploit vulnerabilities on all the team's networks, take down their services, deface websites, and do a bunch of generally harmful things that will lose you points in the competition. So although it's really important to make sure that your network is accessible by the scoring engine, it's really important to also make sure that it's as inaccessible to the red team as possible. I'm going to briefly explain NAT. It stands for Network Address Translation. It's basically just a way to conserve IP addresses. Usually in like a home network, you'll have a one-to-many translation. So to explain this is within easy way to explain this is within your local network, when you're trying to refer to or send traffic to other servers or other computer devices within your own personal network, you'll usually use the local IP, which will be like 192. Maybe let's say one web server in this example is 192.168.1.30. And then you also have another file server that's 192.168.1.15. Maybe you have some laptops or computers that are like .40 or some other arbitrary value. Do they use Cisco devices at the competition? I believe not usually. I think we had Palo Alto stuff. What was our router at the competition, Evan?
It was, oh, we don't get access to the router.
Okay, never mind. We don't get access to the pod router. We do get access to the switch, which is connected to the router, which our switch was a Palo Alto switch? Juniper switch. Never mind. Okay.
Didn't we
Yeah.
have a
So
Cisco at NATS?
basically your source IP within your local network will be all have its own sort of last octet, right? Every device will be identified by its last octet. But usually for people outside or for the sake of accessing the internet or other things, you don't need to give all your devices their own IP to be publicly accessible on the public internet. So it will translate when you send traffic through your switch and through your router. When it leaves to the public internet, it will translate all your source IPs of your local devices to a singular public IP or WAN IP or wide access network IP address. So to the public internet, all the traffic coming from all these devices, .30, .15, whatever they are, will look like, in this example, a traffic from 172.16.30.144, because everything's getting translated and converted to one IP address when connecting to the client or whatever else is trying to access your network. There's other types of network access translations, though, that are important to understand. There's also one-to-one net. These are direct translations of local IPs to wide access network IPs. So for one-to-one NAT setups for a computer network on your router, what it will do is generally it will assign for your public IP address, your global wide access network IP address. You'll have the first three octets will be set, so it'll be like 172.16.30, and then it will directly translate all the final octets of your local IPs to final octets of public IPs. So all of your devices can be accessed individually from the public internet. So instead of all having to go through, as the last example showed, .144 to just hit your router and hit your network generally, all your devices will be translated to their own public IP addresses that are all individually sort of accessible on the public internet. So in this case, now your web server, I guess you have two web servers now instead of a web server and a file server. But now both your servers are individually accessible by giving their respective .30 and .15 IPs at the end of the public IP address. So a client could theoretically connect to individual web servers. Port forwarding is a little bit different for the person that had a question about that. That's sort of done. I think usually port forwarding is done when you have a one-to-many translation and you need a specific port or service on a computer hosted on your network to be accessible. That's what that's for. You don't really need to do that if you have one-to-one NAT, because you can specify the specific device and specific port that you want to access from outside the network, from the sort of, I guess, wide area. So yeah, generally with one-to-one NAT, you don't need to do port forwarding. All right. Now we're going to be talking about the client server model. This GIF here, I really like it. I think it's a really good example of when the client server model fails. These are the food delivery robots. You've probably seen them driving around campus or just around in general. I think the videos of them like falling into things or like bumping into stuff or not knowing where to go are like really funny. Yeah, we actually do have those. I've seen them on campus, but yeah, this is one that caught on fire somewhere. I don't know how that happened. All right, so the client server model is pretty straightforward. You can think of it like in a restaurant, how you have a server and someone requesting the service, or in this case, in the example of a restaurant, they're giving you food. So let's say you had a file server that you're trying to access from outside of the network or just from some other location. That device that you're trying to access it from would be the client in this instance, and the file server would be the server. So generally how it works is a client will send some sort of request or attempt to connect to the server. In this diagram, by the way, the little cloud in the middle is just, I believe, the internet. So in this example, there's a server that's connected to the internet, and there's a client that's also connected to the internet. And so the client would send the request or attempt to make the connection, which would be like the person of the restaurant placing an order on the server, and the server would, if the request is valid or the connection attempt is valid, would I guess reply with something. In this instance, a file server would reply to access to a file directory or specific files. And in the instance of this analogy, the server at the restaurant would respond by giving you food. In some instances, like web requests, this client server model is sort of on a case-by-case basis. So request is sent and responded to, but sometimes there's also instances where there's just established connections, and once the connection is made between the client and server, data can be transferred freely. So yeah, we're going to be talking a little about ports, which are pretty important. We've already kind of gone over what IP addresses are. They're ways to, I guess, refer or identify individual networks or individual systems on a network. And so ports are really important to use along with IP addresses, because ports are the way that you know what specific service or socket connection you're trying to establish on a given IP address. So port numbers usually correlate with a specific service running on a device. So some common ones would be port 20 and 21 are usually used for FTP, which is stands for File Transfer Protocol. Port 22 is usually used for SSH or Secure Shell, which is a remote access service. 25 would be SMTP, which is a mail service. 53 is usually used to identify DNS, which is the way that URLs or domain names like google.com get translated to IP addresses, and you can hit Google's website by typing in google.com instead of the IP. HTTP, which are unencrypted web servers or web server connections, is usually on port 80, and then SSL encrypted web connections are usually on port 443, and there's a bunch of other common ones that are usually what these services are hosted on. But it's also really important to be aware that none of these services have to be hosted on these ports. These are just usually what they're on by default. They could be on any arbitrary port. So it's important to keep that in mind if you're trying to identify or access a service on a machine. If you know that there's a specific service running on a specific IP and you can't access it using this port, it might be on a different one, or it might be firewalled off. You want to say something? Oh, okay. Did you fix the problem? Yeah. Oh, wonderful. Oh yeah, quick announcement. The problem with the template deployments are fixed. So you're now all free to deploy your templates. It should work. If anyone's still having problems, let us know and we'll address it, but it should be fixed now. So people shouldn't be getting errors anymore. Sorry about that. Yeah, so now we're going to briefly talk about TCP versus UDP. These are two different sort of connection protocols. So when you establish a connection with a port, there's different ways that packets can be sent and formatted, and different ways that their data can be validated. In the example of TCP, it's a slow but reliable protocol. It has things like synchronization and flow control, and most important, a TCP handshake, which is, I think we have a slide on it later, but it's basically a way to establish and make sure a TCP connection is valid. TCP also has something that UDP doesn't have, which is that it validates and makes sure that all of the packet data is correct. So if packets are corrupted or a TCP connection is made and there's not the right packet sent, it will sort of wait for that data it will send a signal that it's still missing some stuff, and the server, client, or whatever the connection is to will try and, I guess, send that missing information or address that problem so that all the correct data is transferred and there's no errors or corruption. UDP is a little bit different. This would be the kind of protocols that like you would use, I guess, when like watching a video on YouTube or Netflix. It's a lot faster than TCP, but it's not as reliable. And like I said, like it says here, there's no error checking or acknowledgements. It's literally just sending data to a specific socket. So a good way to understand this would be like when you're watching a movie or YouTube video, sometimes the quality gets a little bit weird, or some pixels might be wrong, or it might look a little bit funky. That's because not the correct packets were sent. But it doesn't really care, because the goal is just to give you quickly streaming video, not to make sure it's 100%, all the data is 100% accurate all the time. And there's lots of different services that use TCP versus UDP. For instance, like HTTP or HTTPS, which are like web services, use TCP, whereas like DNS uses UDP. You just sort of have to know from service to service what it uses. Sometimes it's intuitive, sometimes it's less. But yeah, that's a basic high level explanation. Evan, do you have anything else? Do you have anything else you want to add?
Just go over the DNS is UDP.
Yeah.
That's the one.
Okay, yeah, DNS is UDP. You need to know that. Yeah, so this is just a quick example of a TCP handshake versus how UDP works. So on TCP, it sends, what happens is the sender would send to the receiver a message SYN, and the receiver would respond by concatenating ACK to the end of that and replying with SYN ACK. And then finally the responder, or the sender, responds with ACK, and that sort of establishes a handshake or sort of long-term connection between the sender and receiver. So there's now an established network connection between the two. Whereas versus UDP, where the senders, or I guess the sender, or sorry, the receiver sends a message to the sender that's like, hey, I want you to start sending me this data, and the sender just responds with all the data. And the receiver just like gets it and like uses it to the best of its ability. Is there any other details you think are important? Yeah, okay. Yeah, so now we're going to be talking about what are sockets. It's IPs are related to sockets, ports are related to sockets, and vice versa, and IPs are related to ports. Basically, sockets are the pairing between an IP, which is an identifier for a specific device, and a port, which is an identifier for a specific service. So a good example of this here would be a socket connection between these two different devices with these two MAC addresses. The device on the left is identified with 192.168.1.10. The device on the right has the IP.58. And in order to establish a single connection, they don't just need to know each other's IPs, but they also need to have ports that they're establishing to, that they're connecting to. Because otherwise, even if it knows what device to send the data to, it doesn't know what socket on the device to send the data to. So in this example, the one on the left would have probably an ephemeral port. It would just get some random high number port to establish a connection with likely a web server hosted on the device on the right, which is hosted on port 80. And then they would, in the process of establishing your TCP connection, they would sort of validate that they can establish a connection between these two sockets, between the IP on the left, .10, and the port 57138, and the IP on the right, .58, and the port 80. And then after that connection between those two sockets is established, it would then be able to transfer data between the two machines. So there.
You can kind of think of this like an IP address is a house. So you can kind of think of this like an IP address as a house, and then a port number is a room, in which a room, in this case, is like a process on your computer. And so you don't need to just know which computer to get to, you need to know which process to send data to. So that's what the port numbers are doing.
All right. Oh, yeah, okay. This is for the why of why this is important to understand from a security standpoint as well as a competition standpoint. One, understanding, just having a basic understanding of IPs and ports and connections is really important for identifying weird or abnormal traffic, or differentiating between different services or where traffic is coming from. It's also really important to understand troubleshooting different services. For instance, if you have a service running on a computer, but you can't connect to it, it's not necessarily because the service is broken. It could be because your network is configured improperly, or maybe you have a firewall blocking access to that port. Or maybe the NAT is messed up on your router. And there's just sort of generally a lot of things that you need to make sure you have set up correctly from a networking standpoint to make sure that all your services and devices are functioning properly. I want to add to this. Awesome. So really quickly to review everything, there's two main protocols you have to know, TCP and UDP. There's one more that's pretty much just used for pings, usually called ICMP, but you don't really have to worry about that too much. And there's also other protocols, but those are the main ones. Once again, TCP establishes a connection with error checking and validation, a bunch of other stuff, to make sure all the data sent between a sender and receiver and vice versa is completely accurate. And UDP just makes sure to transfer data as fast as possible with no error checking. Common TCP services would be like file servers or web servers, and common UDP services would be like streaming services or DNS, domain name services. Ports are numbers that identify a specific service or application on a given device, which is identified by an IP address. Like the analogy Evan gave, an IP is a house, and then a port is a specific room in that house. Like you wouldn't want to go to a bathroom to try and like make something in the kitchen. Like that doesn't make any sense, and it wouldn't work. Some common ports that we went over, like port 20 and 21 for FTP, file transfer protocol, port 22 for SSH, 80 and 443 for web servers, and then we also talked about source and destination addresses and ports. I mentioned ephemeral ports earlier, but I didn't really explain it. Ephemeral ports are ports that aren't necessarily like statically tied to a specific service on a device. They're just a port that's used from a connecting device to establish a socket connection with another service on another device. So for instance, if you're trying to connect to a website on your personal laptop, that website is probably on port 443, but the socket on your computer that's connecting to that server is likely not going to be port 443. It's likely going to be some arbitrary port that your computer assigns to establish that connection in that moment. And yeah, so those are usually client side, because usually the server will have static ports that are accessible and the client will sort of choose a port on a case-by-case basis. And then, yeah, we talked about sockets, which are sort of the correlation between an IP address and a port in order to identify a specific process running on a device. So yeah, now we're going to talk about firewalls, which is probably the most important thing to understand for the competition. They're kind of ways to either block traffic or allow specific traffic, and are really important in competition to make sure that red team is not able to do literally whatever they want on your devices at any given moment. Yeah, so there's a lot of different cool things firewalls can do. They can block IPs. You can block an individual IP. For instance, you're like, oh, this IP is probably an attacker. I don't want them to access my network anymore, so I can just block their IP address. Or you can block a whole subnet. So if there's, I guess, a whole range of IPs that you don't want to be able to access your network, or you don't want to be able to hit, you can block those as well. You can block individual ports. So you can say on this device or through this router on this entire network, I only have web servers running and only web servers should be accessible. So I only want to have port 80 and 443 open, and everything else should be blocked. And you can also do packet filtering, which, do you want to explain this at all?
Oh yeah. So with firewalls, a very important concept is a direction. And in our bottom, I think we explained that in a future slide, but yeah, in our bottom point here, it says ingress and egress, right? So a difference is ingress is traffic coming into your network, egress is traffic leaving your network, right? And firewalls are very good at, filtering based off of these rule sets of, oh, I want this specific traffic coming in, I want this specific traffic going out. And with that combination, you can make very strict traffic rules. And a lot of it is determined off of application data that's in the packets, IPs, ports, anything like down to the type of port it's coming in on. There's a lot of different filtering you can do.
All right, so this has a lot to do with the ingress and egress, I guess, rule sets that you just mentioned. But there are two main different kinds of firewalls you have to know about. There's host level firewalls, so you can have, for instance, a Windows firewall on your Windows computer, versus network firewalls, which are usually either dedicated hardware devices or like on a router or a switch that can filter traffic for your entire network. And I unfortunately forgot to put graphics or anything on the slide, so I'll do my best to explain. But host level firewalls only can filter traffic going in or out to a single device. So for instance, you can say, I want on this machine is hosting a file server, so you can set rules for inbound and outbound traffic for that device to only allow the port that your file server is running on to either receive or send data on that device. Versus network firewalls on like a router are a little bit more confusing. You have to think a little bit more, because not only do you have to worry about inbound and outbound traffic, but you have to worry in two directions, because you have one direction, which is your local network, which the router is connected to. And you have the other direction the router is connected to, which is the wide access or wide area network, which is could be the internet. It could just be a larger, I guess, part of a local network. But basically you have to worry not only about traffic in or out, but also what direction the traffic is coming from, whether it's coming from are going outside your network or trying to enter or leave from inside your network. So you'll generally, on a host level firewall, you might have two different rule sets. You'll have sets for inbound and outbound traffic, usually, as opposed to also forwarding some other stuff you don't really have to worry about. But on a network firewall, you will have generally 4 different rule sets, because you'll have to worry about traffic coming inbound from the wide area network. You'll have to worry about filtering traffic leaving to the wide area network. And then you also have to filter traffic entering your local network and leaving your local network. So it makes things a little bit more complicated. But with enough practice of setting up like firewall rules and stuff, you'll get more used to it. You want to explain this?
So recently, there are 2 main types of firewalls you'll encounter. One is a next generation firewall, which is a lot of enterprise kind of hardware dedicated firewalls that you encounter. And then a traditional firewall, which is going to be the majority of your host-based firewalls, like Windows firewall, Linux, it's called IP tables. But in our networking week, we typically focus on traditional, since next generation firewalls are very expensive. But we managed to get our hands on one. So you guys will be able to play around with a Cisco firewall in the homework this week. Yeah, the main difference is next generation firewalls can keep track of a lot more things than your traditional firewalls can. So when I specified like application filtering, port protocol, things like that, that's more of a next generation firewall. You can set up like decryption policies to see where all your employees are browsing to in their free time and block them based off of their like little domain name that they're searching for, right? If you've ever been at work and try to like, I don't know, go to Steam, they'll probably block you. But yeah, it gives a lot of visibility into your network. You can see like, you know, where is the most bandwidth going to, right? What websites going to, what type of protocols are being used the most. And there's a lot of security features, right? So there will be like threat inspection from Snort in our Cisco case. And then, yeah, IPS and IDS are integrated. That's Snort, something I mentioned. You can look that up. We won't be going over it this week, but it's a very cool tool to identify malicious traffic. Oh yeah, they'll block Minecraft. Yeah, traditional is just like the filter on IP, filter on port. There'll typically be stateful, like the next generation firewalls, because new traditional firewalls are still more advanced than old traditional firewalls. Yeah, a little complex there, but there's just less functionality in a traditional sense.
Yeah, I just realized we do kind of have a graphic for the difference between host and network firewalls. I'm just going to really quickly go back to one of our example slides for this basic topology. You might have a network firewall on the switch or the router, and as you can see on both those devices, there's, oh gosh, it's kind of dim actually. Here, this is a better example. On your routers, you can see there's like multiple interfaces or ways that they're connected to different networks. So there's multiple lines going in and out of them. All those lines you would need to make your own rules, like specific rules for, to filter traffic going in and out of those connections. But for host-based firewalls, which would be like these servers or workstations you can see sort of on the edges of the network, there's only one I guess network interface going into them that you really have to worry about or make rules for. So yeah, that might be a little better way to visualize it. All right, quickly we're going to talk about stateless versus stateful firewalls. Stateless firewalls look at did you have like a rant you want to do for this, or do you want me to explain it? Okay.
Yeah, explain, try to explain.
All right, so I mean the high level explanation, as I understand, is that stateless firewalls generally don't keep track of traffic going through your network or into a device. So you have to set individual rules for traffic coming inbound, traffic leaving your network. You even need specific rules for traffic going to your own device. So like you might have to allow You might have to have a loopback rule to allow a web server to access another service within your own device, because it doesn't really check the state of traffic or care about where it's going to. It doesn't really care about where it's eventually going to. It just sort of cares about the like connection or direction that it's trying to go in an individual moment. Stateful firewalls are a little bit different. So they keep track of the flow. They keep track of the flow of network traffic. So instead of having to set like an individual allow traffic in on port 80 and an individual allow traffic out on port 80 rule, you can just set an allow in rule. And if anyone establishes an inbound TCP connection, if anyone tries to establish a TCP connection inbound to your device, it will keep track of all the connections that are really quickly being made back and forth, and understand that this response is directly correlated to the request that was made inbound. And you won't have to have separate rules for it. So a single allow inbound on port 80 rule would suffice to allow that sort of data to flow.
Yeah, that was spot on. Also, typically your stateful traffic will be your TCP connections, and then your stateless will be UDP or other protocols. But something special that Linux commonly does is track state for UDP connections and maybe some other protocols. So where you can configure your firewall as if it was stateful for UDP connections, but in reality it's doing some kind of voodoo magic behind the scenes state tracking of UDP. And not all devices will do that, and you'll realize that as you configure different firewalls, that sometimes UDP traffic will behave differently.
All right. I don't know. I think you made this example, so you want to do the firewall example.
Let me remember this example. This is just a firewall rule set to allow your wanted traffic and then deny all your unwanted traffic. There's not much more I can say about this. It's just if you were to put firewall rule sets in like normal English, which is interesting.
Yeah, I guess the point of having the malicious looking devices both inside and outbound of your and outside of your network is to show that it's important not only to block people from or block malicious traffic trying to go inside your network, but also outbound, because a lot of time malware will function by calling out within a device on your network to some sort of server external to your network. And if you don't have rules to filter traffic leaving your network, you don't really have a way to stop that. So it's important to not only care about what's entering, but also what's leaving. Here's a wonderful example of a WAN firewall. I believe this is on a pfSense router, I think. Yeah. So this is an example of a network level firewall that will have two interfaces. So there's the WAN or wide area network interface, which is the Ethernet cable or connection that's connected to, in this example, let's just say the internet. So that's the part of your router that's plugged into your modem and your internet service provider. And then your LAN interface is the network interface that connects to your home network or local network. So here you have your rule set for your WAN interface, which looks like it is allowing all traffic on all ports to this specific source IP, I believe, inbound and outbound, it looks like. So this just is a rule that allows all traffic in or out for. Oh, is this inbound? Where does it say? Oh, well, yeah. This allows all traffic on WAN through. The next example of the local area network firewall is this rule set, which appears to be allowing all traffic on ports 443 and port 80. So it says it's described as an anti-lock lockout rule. So,
I mean, LAN address is.
oh, LAN, okay, so the destination here, LAN address, I guess, is referring to the router. So this is a rule that allows you to access the web server hosted on the router, which is the web interface that you're seeing right here. Is accessed through port ID or 443. Generally the way, if you're not using like a direct connection, like if you're not directly wired into the router and you're trying to configure things, you'll have to access it through the web interface. And if you don't allow any traffic within your local network to that web interface, then you can't access your router. So it's important to make sure you can do that and change rules. This next rule looks like it just blocks all of their traffic on the LAN to or from the router. And then these last two are specific rules that allow traffic within your network, I guess, to flow. Was that allow LAN to any? Oh yeah, so the way that firewalls usually work is they evaluate rules in order. So these last two rules, which are allow traffic for the LAN network, would never actually be evaluated because all the data connections made before they even got to that point would be blocked by the prior rule, which doesn't allow any traffic that isn't trying to connect to the router web interface. So these last two rules are irrelevant. They're not doing anything here because all the traffic that they may be allowing is already being blocked or dropped by the rule that comes above it because it's evaluated in order top down. We're not doing a firewall demo. I don't know why this slide is here. OSI model. We're not going to talk about this because it's a little bit too much information than what's necessarily important for CCDC. If you're interested in learning more about computer networking, look into it. But yeah, we definitely don't need to explain this for the case of this workshop and the point of this this introduction. So at this point, I know that was all probably very confusing if you don't have any experience working with computer networks. But what is the OSI model? I'm not telling.
There's a lot of write-ups on that.
There's a lot of write-ups online that you can look up if you want to know. What is an OSI model? Yeah. If anyone has any questions, this is a great time to ask before we get started in the lab. I know for me, at least, when I was first trying to understand a lot of these concepts, this was probably the hardest thing for me to learn was like computer network concepts. So if anyone has any questions about anything we've gone over, feel free to ask, please. We'll be on.
Did it explain?
The homework is going to be pretty somewhat technical and involve all the things, pretty much all the things we just went over in the slides. So if anyone has any confusion about anything or they're unsure about something, now is like a really important time to ask.
I have a question.
Okay, for sure.
For the competition, do you use real hardware equipment?
For I mean, it's a mix. Some servers in our competition are connected to like a local switch that's actually there that we have like physical access to. Some services are on the clouds. They might be like AWS services, or just some sort of remote server that we don't have direct physical access to, but we can only connect to remotely. And so that definitely changes how careful you have to be for things like setting like firewall rules, because if you, for instance, set a rule that blocks your access to that remote network, you just no longer have access to it because you can't like physically access it.
Build your own networks?
No, in the competition, for people online, someone just asked, do you create your own network? In the competition, you're given just sort of a pre-made company network. It generally has like a lot of misconfigurations. It doesn't have like security stuff set up usually. There's usually no firewall rules, no nothing. But generally, you're given to start a functioning network that can connect to the internet and the scoring engine can see with all your sort of services running on all your servers. And your job is sort of to secure it and make sure that red team can't break any of the stuff on your network while also trying to make sure the scoring engine and the orange team, which is like the pretend customers, can still access all the stuff they need to access.
Are the red teams and the blue teams both, like, are they all, like? Students? Are they students or?
No, can red team be students? No,
Not
Red-
every part of like,
yeah, red team can't be students because you can't like compete in CCDC while also being on the red team. It's a group of, they're volunteers, right?
Yeah.
Yeah, it's a group of like offensive security volunteers that sort of act as like a fake, like a competition, like threat actor for the duration of the competition. And as student competitors, you're on the blue team just trying to do all the defensive stuff to secure your network. So a lot of like firewall rules, like network IT stuff, like fixing like common like vulnerabilities, that sort of stuff. Yeah.
But the slide you showed with an example of a network, that would be it? That's the size of a network?
Yeah, so maybe I don't think I actually said this, but for this competition topology, we went over earlier. All this stuff in the yellow is out of scope for the competitors. So in the competition, the only thing you really have access to are your servers and your switches. For whatever reason, I thought we had access to the router, but I guess not.
oh, in regionals we have access.
Okay, access to the router depends on the competition. Like at regionals, we had access to our router. At nationals, we didn't. It can depend from competition to competition. But all this stuff in the yellow is completely out of scope. So as a blue team competitor, you're not allowed to, you don't have access to it. You're not allowed to try to access it. If you do, that's like very big, like that's like a big violation of the rules. So yeah, you generally don't have to worry about any of this out of scope stuff. Someone just asked, will non-CPP students not be able to do this homework since having access to CommuniPod through elsa.sdc.cpp? No, I believe non-CPP students can also access elsa.sdc.cpp. If
No, not STC, that's a place with network.
oh, elsa.calpoly.org.
Yeah. Oh, wait, also the STC. They need, everyone has the VPN, right? Like, you just sign up.
Yeah.
Oh, yeah, they should be able to.
Yeah, okay, sorry. If you have the VPN config, you should be able to hit elsa.sdc.cpp. If you do have your VPN configured and running and you're connected and you still can't hit the website for some reason, let us know. Oh, is it HTTPS? Okay. Yeah, you should be able to access it even if you're not a Cal Poly student. Any other questions?
Can I ask something real quick?
Anyone confused about? Oh, anyone confused about NAT at all?
We'll be using it.
This is important for the homework. All right, if there's no more questions, we can get started on the lab. If you haven't deployed or redeployed your pod already, make sure to do that now. You're gonna need to use it for the homework. I guess I can quickly just go over and describe the homework really briefly, if anyone, just to address maybe any common questions. But yeah, it's time to get started. It's gonna involve setting up host and network level firewalls, as well as changing the network the NAT rules on the router. So it's going to involve a lot of stuff we went over today. So yeah, if anyone has any questions, still feel free to ask for the rest of the duration of this meeting. And if the meeting ends, feel free to ask on Discord. We'll do our best to help you. But yeah, it's time to get started. Let me go back. actually to the homework link again, so everyone knows how to access it. Yeah, that's the homework thing. Gabriel Adams asks, I'm able to access the website, but is the VPN needed to open the VM? If you can access the website, then your VPN's connected properly. So yeah, you would also need the VPN to open the VM. If you're talking about like using like remote desktop protocol or like SSH to connect instead of like vSphere, you would need the VPN in order to do that because all the VMs are hosted on the private network. Do I need to download a VM to do this lab? No, everything is hosted on the student data center. So you just have to access vSphere, and you can either use the you can either directly access the VMs hosted in vSphere through the sort of web interface and just popping them open there. Or like I said, they're Windows servers. So you could also access them through RDP. I think they have RDP on, or it shouldn't be blocked. But yeah, the RDP is probably more trouble than it's worth, especially because you're gonna be doing like firewall stuff. So probably just access through vSphere. For vSphere to ask for an email and password, you don't need an actual email. It's just put in your username that you use for Camino. Even though it says an email, just whatever username you registered on Camino should work for vSphere as well. It's the exact same login. It's not your student credentials.
It's just I was direct over. I've been like this kind of spamming people for a while. And then I decided I saw in your can delete your account. I was like, I don't have to delete my account. I can just delete my account and come back. And it worked the first time. And then the second time I did it, I was just thinking. When I went to sign up, it was like I like at checkout, it was like give me an error. So like they don't just go register because like they go but I didn't have it like process it. I didn't like you did process, and then I just filled out my info again, and then also I was doing it whatever. I always switch it to monthly in case like I mess up. For reloading page on an air, the default to yearly description. So I'm on a yearly. I refill in my info, and then it just instantly charges like a year. For this period, that is more like a straight line. It is like that, right? Oh, I had to get my credit card. Udemy support is basically long. I mean, it would make sense. Their policy aids, they give no refund.
Thanks for teaching me a thing or two. Yeah. See you later.
Yeah, I think
All right, so if anyone is still confused about the setup of the homework, the instructions for actually deploying your virtual machine template is on the initial setup part of the homework, and then all the deliverables are below. To be clear, sorry, for the deliverables on the homework, it specifically asks for screenshots of certain things. That doesn't mean that's all you're supposed to submit for the homework. Remember the business week, we want write-ups with explanations of what you're doing that are easy to follow. It's gonna be graded not only on like the evidence given, but also the format and readability of the whole homework submission.
I like how. This is like way.
Yeah, one really important thing though for the homework is on question 2 or deliverable number, oh sorry, on
It's around 6.
question 3.
2 days.
The first step is to set the outside or wide
2 days.
access network interface to have an IP that is exactly 172.16. The number that was given to your pod that you deployed .1. I guess it doesn't have to be .1, but just make it .1. This is really important to do before you do any of the steps after this. And if you don't do this, it could potentially cause like overlap issues with other students participating in the workshop. And it could make your homework very hard to do. So make sure you do deliverable 3A or question 3A before you do any of the steps after it. Don't start red teaming other people's homework, Elias. I will actually like ban you from the boot camp. Don't do that, please. I'm watching you, Elias. But yeah, we'll be here until 4. So if anyone still has any questions, you're lucky. I don't know how to do that. Yeah. If anyone still has any questions until 4, I'll be free to answer it on Zoom. And if anyone has any questions after that, after the Zoom meetings ended, ask in Discord. Make sure to ping me because I don't necessarily check super often if I don't get pinged. If you send a message and forget to ping me, don't edit it and ping me, just resend the message with a ping, because if you edit and add like a ping, it doesn't actually ping me. So yeah.
What do you want me to do?
Or you can ask each other questions and help each other too. That's also fine.
Just click random one.
I had to get more assigned.
It's got all the.
Grayson asks, how do we do that? How do we do what, Grayson? Can you specify a little bit more? Thank you. Rachel says, are you supposed to not be able to access the XAMPP web server on the 2022 server? To start, both of the templates or both of the Windows Server VMs should have 2 web servers running. If any of the web servers aren't running on any of the templates, you should start them back up. If you don't know how to start them back up, XAMPP is really easy. You just go into the XAMPP interface and you start it. You press start on Apache. For IIS, it's a little bit different, but also pretty easy. You can look it up. Yeah, so my pod number is 1887. Would I use 188 in the IP? Oh, sorry. Let me be very clear. I should probably also edit the homework. For your IP, your pod number is the last 2 digits of that number. So your pod number isn't, even though your pod number is 1887, you would set the IP to .87 because the only values that differentiate from participant to participant are those last 2 digits in that number. So it would be 172.16.87.1.
You got nothing last time. You still
Thing is, this convening thing, it's actually
It's actually crazy.
you change the abbreviation.
Yeah.
I'll change that in the homework doc right now. Thank you for pointing that out. Maybe have the slide link posted in the homework just for this moment.
It's 5 turns.
Uh,
70%.
Sure. I'll post it on, actually, I'll just post it on Discord like right now so everyone has access to it.
Then listen.
No, I already played Battle Stars again and I don't like it anymore. It's so boring.
I like peeking for
900's crazy, no? 900's crazy.
Yeah,
no?
that's crazy.
Like 1,000, like the max.
Sorry, now we get like 35 like
Can you?
I think I should get like that.
The homework doc should be in the Discord now for the person, or sorry, the slide doc should be in the homework now.
Yes, I don't have any game.
What they probably got to see.
Yeah, I got back on TikTok.
But I'm still glad you not.
I'm hoping you're not too bad.